Hello everyone, I am Rudra Dhara. I have just completed my Bsc in Physics from Ramakrishna Mission Residential College. I have ranked 8th in IIT JAM and ranked 26 in the examination of JEST. I also cracked TIFR Mumbai and IMSc. So, in this session, I am going to present my interview experience with you, as well as I am going to give some IIT JAM and JEST preparation tips. So I will go to the slide and then we will begin. So as I have said in my introductory video that I have ranked 8th in IIT JAM, I have ranked 26 in JEST, and as well as cracked MSc and TIFR Mumbai. So let's talk about myself. My home village is Jaipur, which is in Howrah district of West Bengal. Now, from my childhood, I actually was interested in physics, and I was selected in Ramakrishna Mission Residential College Physics Department, and I have done my PhD from there. To say about my achievements, I have said it before. I also am an inspired scholar. To say about my hobbies, I actually play tabla, and in my home, when I come to home, I enjoy gardening as well as cooking. Now I'm coming into the preparation section, so I will tell first about my BSc journey. So in first semester, I think we all face same kind of problem, that suddenly the syllabus was getting huge compared to the higher secondary syllabus. Now, so finding good books is important, and it is also important for competitive studies. Then another advantage I enjoyed in Ramakrishna Mission Residential College is that hostels, that you have seniors who actually are in the phase of preparation in their JAM JEST TIFR exam, and your some of the seniors already have cracked JAM JEST exams. So I get tips from them. So don't worry, I will share my tips here. Uh, so uh, for preparation of JAM JEST, we also take a test series, and in the COVID time, the Physics Galaxy Challenge was very helpful for me. So let's go into the book uh, which I have studied. So let's talk about the books. So for mechanics, Kleppner-Kolenkov is a very good book, and I think you should practice the problems of Kleppner-Kolenkov. So after practicing the problem, I think you will have enough background for any competitive question. Uh, Another book is Stackwell and Puranik. So it's also a very good book, and it has it is more theoretical, and focused on advanced topics. And Kleppner is a kind of basic book, but the problem is very good in Kleppner. Uh, for advanced classical mechanics, we have to study in our 5th semester. I personally follow the Thornton-Marion book, which is a lighter version of Goldstein. So Goldstein is very good book, but I follow Thornton-Marion. Thornton-Marion is also very good for relativity. Another good book for relativity is David Murray. For mathematical methods, I think Boas is very good book for introductory uh, mathematical physics. For beginning, I think Boas is the best book. It have theoretical aspects, theoretical concepts, as well as the problems to practice. So I think it is the most complete book for BSc. H.K. Das is also good book for practicing problems, and for vector analysis, Spiegel is good book. Another book is Riley Hobson Bates, which is more advanced book, and more focused on MSc. So I think Boas and HK Das and Spigel is enough for PSC. You can follow Riley Hobson also if you like. For waves, if you French is very good book. It have very elaborated concepts, and the problems are also good and lengthy. But so another good book for waves and octaves is Pain, 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 and you can follow other book also. Actually, wave and doesn't matter much. And now coming into the optics, Hedged and Ghotok are very good book. So Ghotok and Hedge are kind of same level. So Hedge is have more theory than Ghotok, so you need more time to reach Hedge. Ghotok is also very good book, so you can follow any one of them. Uh, uh, then is Garg Bansal course for thermodynamics. I only followed Garg Bansal course, and I think it is sufficient. And for electrodynamics, I followed only Griffiths, and I think Griffiths is very complete book. So you will have all the concepts, and very important to the important is to practice the problem of Griffiths. So it will give the grounding concepts. Now coming to the quantum and modern. For modern, I think you should follow Arthur Weiser. Arthur Weiser is very good book. It covers from the beginning of quantum mechanics to quantum mechanics and modern physics like uh, nuclear physics. So mm, it is very complete book, and the nuclear physics for JAM, JEST or TIFR, I think Arthur Weiser is enough. Now for advanced quantum mechanics, for JTL is good, not advanced actually. So uh, for the deep knowledge, so JTL is good, and the problem in JTL is are also good, so you can follow the problems. And another thing to mention is the MIT open course quantum mechanics 1 by Barton. I personally followed this course during COVID, and I think it is one of the best quantum mechanics course for PSC. So another course is HC Verma. So you can follow HC Verma sir if you like, but I personally followed the Barton's Webex, which is very good course, and you will feel quantum mechanics in this course. Now coming into the electronics, so Millman, Halkias and Boylsted are two books. So Millman is more theoretical and give you the how the things work. Boylsted is kind of mechanical book, and but it is good for problem practice, especially a clipper clamper problems and op-amps problems are good in Boylsted. Millman, if you want to understand the semiconductor flow, etc., then you can follow the Millman. For advanced topic like nuclear, stat mech and relativity, and these books are given, but this topic are not much important for the competitive exam. Stat mech is little bit important, so it can but for the basic stat mech is only needed, not much. uh, and relativity is important. Sometimes some problem of relativity, uh, there can be problems in relativity in jam. So Thornton Marion is good book for basics, and it is, I think it is enough for competitive exam. And David Morin is also good book. So these books are basically not particular relativity book, but they are classical mechanics book, which in some part they have relativity. So you can follow them. Uh, so coming to the preparation of competitive exam, so problem practice is very important. You can practice the previous year questions, and there are many PDFs available of the problem, so you can, if you can find it, you can practice it also. If you can afford, you can uh, buy some kind of um, reading material, study material from different website like Physics by Physics and a Career Endeavor Unacademy. But I think if you practice, if you can find the PDFs for free, then I think the other thing will not much matter. You can practice any problem you can find, and uh, of course you should uh, keep in mind about the standard of the problems. Another is Samvedna book. I actually have followed there is a book by Samvedna publishers which have all the previous year in a same book, and they have divided the question chapter wise. So like for mechanics, all the previous year question are separated, then they separate the quantum mechanics one, and not only jam, just TFRs are also included. So this is a good book, and I followed it. uh, then you can also find some PDFs of the problem. So don't worry if you don't want to buy anything, you can practice from the PDFs. It only matters, doesn't matter which publisher you study actually. Then uh, while practicing the problems, I think you will find out your weak spots, and you have to clarify the spots. You can study books, uh, or watch YouTube video lecture. If you have uh, less time, you can also watch YouTube video lecture or notes, which will be helpful for you. Now mm, if you like, you can take short notes, like some kind of good problems or difficult problems, there is particular tricks. So if you find out the trick, or uh, came to know the tricks from your teacher or fellow students, then you should note the tricks. And this noting procedure uh, is important. uh, Another thing is mock test actually, because the time management is important during any competitive exam. So mm, mock test is important. I personally followed Career Endeavor mock test, which is good mock test series. The question levels are more advanced than jam, and if you can if you solve the Career Endeavor problem, I think it will prepare you for the chest and TIFR as well. uh, and device is also important. So like it is not your semester exam that you have to study certain papers and you have to keep the exam for the certain papers. The whole syllabus is included from your first semester to fourth and fifth semester in jam, and the full syllabus or more syllabus is included in chest and TIFR. So you uh, have to have the knowledge of whole syllabus. Now some key topics to follow. I think every topic is important, and for getting very good ranks, and all the topics are important, and you should at least have the basic concepts about all the topics covered in jam, because there are some questions are very easy. So if you just read one time any topic, you can answer those questions. And so if you have less time of your preparation, then you can focus on mechanics, matrix, and quantum and electrodynamics. So that will help you, because the most of the problem are related to those topics. Vectorial analysis is also important topic. uh, and electronics, especially follow the clipper clamper circuit, they are important. Op amp is also important. So let's come into the interview. So for any interview, you need to have a clear concepts of topics, and I think if you read books over the notes, the concept you learn from the book will help you in the interview. Especially the problems you did in the book will give you a problem solving power for interview like questions. So in interview, it is quite different than jam or any kind of competitive exams, because in a competitive exam there is definite answer, a defined well defined problem, and there are MCQs. You have to choose one. In interview, they in most of the cases they will give you some out of the box questions, and they will also guide you throughout the process. So in interview, always remember that they will give some hint. uh, it is my experience in all of my interview. I have given interview in TIFR, ISC Bangalore, ICTS TIFR Bangalore, and IMSC, as well as IIT Gandhinagar also. And I have qualified in TIFR, uh, TIFR Mumbai, uh, and IMSc Bangalore, and IIT Gandhinagar's one. And IIT Gandhinagar actually interview was for early MSc admits, and I was also in the waiting list in IISc Bangalore. Now I will give my interview experience about TIFR and IMSc. So uh, I, at first in TIFR Institute, the teachers were very friendly. So they asked me about myself, where I'm living, how was I doing in the period of Corona, and they um, asked me about my strong topics. So uh, actually, so there can be two things in during the interview. Sometimes they will ask you the strong topics, and they would ask question from it. Another case will be that they will ask you strong topic and don't ask question about it. It was my The latter was my experience in ICTS. I'll not talk about that. Be prepared for any type of situation. Now they are fortunately they asked me from my known topics, strong topic. I said electrodynamics and quantum mechanics. So first question was from electrodynamics, the charge insulator ring uniform magnetic field. So it is the problem. So this is a ring, so charge insulator ring, and they say it is insulator ring and which is charged, and it is in uniform magnetic field like this. Now, and they said that suddenly I remove the magnetic field, so what will happen? So at first I said, I think as the ring is insulator, so I think there will nothing happen. uh, then they give me a hint. So then they ask me a question. Say, what will happen in case of a um, conducting ring? So for conducting ring, we know that a current will flow. So um, uh, the so thus I actually find the hint and uh, came to the answer that the ring will rotate, the charged ring will rotate, and it is very natural that as the when I are suddenly turning off the magnetic field, so the the time derivative of B is not zero. So there is a curl of electric field. Now the curl always rotate the ring. So this was the answer. Then they asked me about the uh, which speed it will rotate. So at first I said that electric field and magnetic field have some kind of momentum density. So if you read Griffiths, you will know that there is a concept called momentum density and angular momentum density. So I was trying to answer out through that problem, that charged particle and the ring will magnetic field, uh, the charged in the electric field will charge in the ring, and the magnetic field will create some kind of a, angular momentum density, and then we can calculate from that. Now they said okay, but it is hard to calculate. So can you find any easy method? So I think a little bit, and this equation, Maxwell equation, came into my mind. So if you integrate the equation, then you will find the line integral of electric field, and uh, the um, change in total flux, and this from the line integral of electric field you can find out the torque. If the ring has r radius, then you can find out the force and in dr due to the curl in electric field, and you can find out the torque. So thus I said that with this I can find out uh, mm, the speed of the ring, how the angular speed of the ring. And they don't ask me about how to calculate the result, but just ask me about the steps. So I actually tell them like this. Next question is say electromagnetic. So then another professor asked me about, say, have an electron and put it on the table, so what will happen. So uh, I answered, uh, so I cannot get what they were wanting from me. So I first said that it will go into the table and there is atom. So then the electron will interact with atomic field, and uh, uh, which usually happen. But then they said no, we are don't want to uh, ask this kind of question. They said the suppose a ball on a table, so it will cannot penetrate the ball. So consider the electron like this, they cannot penetrate the table. So as they cannot penetrate the table, so I and this is electron, very light particle and small particle, so we should use quantum mechanical approaches. So I said that we consider the hard wall, like at height, say let that this is zero height. So this is hard wall, so potential is infinite at the point of table, and as we go up there is a the potential goes linearly with height, as the potential energy due to gravity is mgh. So it will, this is the straight line corresponding to the mgh, this is v is corresponding to the potential energy. So well, then they asked me about how so is there is any probability that electron can lie on the table. So at first I was telling that as there will be some uncertainty in position, so h cannot be 0. So they said well, but we want a more clear uh, answer. So I at first I wasn't able to give the answer. So then they asked me to draw the wave function. So so the wave function, you have to keep in mind that as this is infinite potential, this side is infinite potential, this side. So at that point at h is equal to 0, the wave function will have 0 amplitude, and then it will go like this and decay after crossing the higher value. So as we see that it should be must be 0 at h is equal to 0, so there cannot be any electron at 0 height on the table, it must be higher in the table. So this was the question. Actually the question was in quantum mechanics. So next is consider is, then they asked, another professor asked me about consider the conduction band and valence band as line, so they don't have width. So I draw them like this. So then they said let consider the electron in conduction band are only responsible for the flow and neglect the holes. And then they asked me about to calculate the uh, to show that how the conductivity varies with the temperature. So it is a statistical mechanics two-stage system. So and the probability in ground state or valence band is this, and probability in E2 is this, which is conduction band. So the conductivity will be proportional to the P2 in the probability of conduction method. So uh, actually it will um, vary according to the probability of P2. So I said that sigma is proportional to number in CB, which is proportional to the probability P2. And they said okay, and just say so they didn't um, told asked me to write the full equation, just okay, and then they asked me to draw the graph. So the graph is like this, and mm, then they asked the next question. So the next question was a series. So it is a well-known series, but I actually forget this series. So in actually my first semester mathematics pass, I actually read about the series, but I somehow forget it now. So they asked me this series 1 minus 1 plus 1 minus 1 to infinity. So what will happen? So I said actually it is oscillating, uh, kind of vaguely said. I didn't know anything, and I have forget the definition of series, etc. So I said the value of it is oscillating between 0 and 1. So uh, if we take first term 0, then add 1, then also minus 0. So in for infinite, I think there is no well-defined values. So they said okay, so but uh, is this a definition of a series? Series should have a particular value. So they hinted me that can you find out any series? So then I it is stuck in my mind that oh, so this is a very well-known series. I know that. So and I actually recall this series. This is up to infinity, not x cube. There should be some three terms. Now, if we put x is equal minus 1, it will get half. So, which is the value of the series? So then they say, okay. Actually, in my first attempt, there is a calculation mistake. So I was not getting half, but I say 1 by 0. So this there is a calculation mistake. I said it may be. So they understand that I was doing right, and as it was in COVID and I'm writing paper and they didn't see what I'm doing, so they didn't guide, they didn't point out the calculation mistake, but they understand that I was doing it right. So they think please redo your calculation again, and I find my mistake and said it. So throughout the interview they give me lots of it, and they are very helpful. So during interview you shouldn't panic much. This is the first tips. And uh, and you actually they see how is your problem solving ability. Mm, so the questions were kind of out of the box for TF, but they are actually good questions and they will hint you. So now I'm coming into the MSc interview. So MSc one was uh, there was three teacher in my panel, and they asked me mainly about electrodynamics question, quantum mechanics, and general physics question. So uh, like other interviews, they also asked me introduction and what is my interest. I said I have interest in condensed matter physics, especially in as IMS is theoretical. Though I am personally interested in experimental condensed matter, but as IMS is theoretical, I said that I am interested in theoretical condensed matter physics. So then they asked me about uh, to say about my strong topics, and again I said electro and quantum. So the first teacher asked me about the electrodynamics question. So they said I have a very simple question. There is a magnetic field uniform and a particle is moving. So I said that will be a circle. So it is well known. Now the next question was what will happen if there is a electric field. Now I actually the electric field will give it acceleration in this direction, so actually it will rotate like this and hmm, rotate like this, as well as there will be a translation motion. So this is like the combination of two motion. Then they asked me to tell about mm, the intercept, like uh, what will be the radius of the, or the what will be the intercept, the uh, radius will change or not change, like this same kind of circular pattern, will the radius will change or not change. So I said the radius word is not well defined here, so if we draw x-axis and the this point intersect in that point and that point, so this length is kind of radius, so in that sense, so will their radius increase or remain same? So I actually remembered one problem, uh, which will get the cycloid motion. And so I said that as in this particular case, this is the motion of charge particle in cross electric and magnetic field. So I, as in that case we are not getting a mm, space trajectory, so the spacing of the each curve is similar, so the x intercept interval of the x intercept is kind of same. So I said that this radius will not increase. So then, but I was wrong in that context. Then they said the electric field will accelerate the charge particles. So in gradually this will the trajectory of the particle will like this, will become like this. So and this was a different case actually. So they said if I put electric field in that direction, so say it is it is x direction, so let's say this is x direction, so that will be the motion. So the electrodynamics question was very bad, but the other part question, like the quantum mechanics and the general physics questions, was actually I have was able to give quite good answers. So now, so the then another person asked me about the simple harmonic oscillator under electric field. So I know a simple harmonic oscillator, then if we apply electric field it will just shift, or origin will be just shifted, nothing special happen. And second question was what is the uncertainty of ground state. So as we know that the particle is Gaussian, the first wave function is Gaussian, so the uncertainty will be minimum. So the delta p and delta x will be saturated to h bar by 2. This is actually property of Gaussian wave function. uh, they also asked me other quantum mechanical questions, mainly conceptual basis, but I actually am not able to remember them at that time. Now another question was considered, this is a wave function of the particle, and this is some hard wall, so the particle cannot penetrate. Now we actually move the wall in this direction, so what will happen? So I said the wave function will increase, and then they asked that what will happen if the wall move in opposite way in this direction. So I also said that the wave function will spread, but the answer was wrong. So the wave function will shrink, so this not spread out, but this will shrink to a delta function. So it was my fault, and I was not able to get the correct answer, but they say it's okay. It is a bit difficult for at this stage because it will need the time dependence origin equation. And then they asked me to solve a differential equation, which is UMF of the particle, which came out to be some tan function. So I forget what was the differential equation, but I remember that this was the solution and this is the curve of time. Then they say consider the particle, and the boundary condition was given that at t is equal to 0 the x is like this. So they asked me that what the time it will take a particle to reach 0 to x. So the answer will be infinite, as t is equal infinite, x will be pi by 2. So this was the question. Then they asked me another interesting question: water bottle open in the moon. So uh, they said, what will happen if I open a bottle of water in moon? So moon have no atmospheric pressure. So I said it will evaporate, all the water will evaporate. Then they asked me, so as it will evaporate, so at first the water will start boiling and all the water will be evaporated. So they said there should be a latent heat as it is changing its phase. So they asked me where it is getting the latent heat. So then I was quite not sure, but I said that uh, the water will start to boil, but the boiling temperature uh, is low. Now as the water become mm, vapor, turns into the vapor, then it will absorb the latent heat from the water itself, and when and at a certain time the water will freeze out. So as the vapor is taking latent heat from the water will cool down and until it freezes out. So certain part of the water will be vaporized and other will be other will freeze to ice. So it was my answer, and they said okay, and it was the end of my interview. So let's talk about the books. So uh, for mechanics, Kleppner-Kolenkov is a very good book, and I think you should practice the problems of Kleppner-Kolenkov. So after practicing the problem, I think you will have enough background for any competitive question. uh, Another book is Stackwell and Puranik. So it's also a very good book, and it has it is more theoretical and focused on advanced topics. And Kleppner is a kind of basic book, but the problem is very good in Kleppner. Uh, for advanced classical mechanics, we have to study in our fifth semester. I personally follow the Thornton-Marion book, which is a lighter version of Goldstein. So Goldstein is very good book, but I follow Thornton-Marion. Thornton-Marion is also very good for relativity. Another good book for relativity is David Murray. Uh, for mathematical methods, I think Boas is very good book for introductory uh, mathematical physics. For beginning, I think Boas is the best book. It have theoretical aspects, theoretical concepts, as well as the problems to practice. So I think it is the most complete book for BSc. H.K. Das is also good book for practicing problems, and for vector analysis, Spiegel is good book. Another book is Riley Hobson Bates, which is more advanced book uh, and more focused on MSc. So I think Boas and H.K. Das and Spiegel is enough for BSc. You can follow Riley Hobson also if you like. For waves, French is very good book. It have very elaborated concepts, and the problems are also good and lengthy. But so another good book for waves and octaves is Pain, Pain, and You can follow other book also. Actually, well, doesn't matter much. And now coming into the optics, Hedged and Ghotok are very good book. So Ghotok and Hedged are kind of same level. So Hedged is have more theory than Ghotok, so you need more time to reach Hedged. Ghotok is also very good book, so you can follow any one of them. Uh, uh, then is Garg Bansal course for thermodynamics. I only followed Garg Bansal course and I think it is sufficient. And for electrodynamics, I followed only Griffiths, and I think Griffiths is very complete book. So you will have all the concepts, and very important is to practice the problem of Griffiths. So it will give the grounding concepts. And now coming to the quantum and modern. For modern, I think you should follow Arthur Weiser. Arthur Weiser is very good book. It covers from the beginning of quantum mechanics to quantum mechanics and modern physics like uh, nuclear physics. So mm, it is very complete book, and the nuclear physics for JAM, JEST or TIFR, I think Arthur Weiser is enough. Now for advanced quantum mechanics, for JTD is good, not advanced actually. So uh, for the deep knowledge, so JTL is good, and the problem in JTL is are also good, so you can follow the problems. And another thing to mention is the MIT open course quantum mechanics 1 by Barton. I personally followed this course during COVID, and I think it is one of the best quantum mechanics course for PhD. So another course is HC Verma, so you can follow HC Verma sir if you like, but I personally followed the Barton's Webex, which is very good course, and you will feel quantum mechanics in this course. Now coming into the electronics, so Millman, Halkias and Boylsted are two books. So Millman is more theoretical and give you the how the things work. Boylsted is kind of mechanical book, and but it is good for problem practice, especially a clipper clamper problems and op-amps problems are good in Boylsted. Millman, if you want to understand the semiconductor flow, etc., then you can follow the Millman. For advanced topic like nuclear, stat mech and relativity, and these books are given, but this topic are not much important for the competitive exam. Stat mech is little bit important, so it can but for the basic stat mech is only needed, not much. uh, and relativity is important. Sometimes some problem of relativity, uh, there can be problems in relativity in jam. So Thornton Marion is good book for basics, and it is, I think it is enough for competitive exam. And David Morin is also good book. So these books are basically not particular relativity book, but they are classical mechanics book, which in some part they have relativity, so you can follow them.